Without further ado, it is my pleasure to welcome Particle's CEO and co-founder, Zach Supalla, to the stage.
Good morning, everyone. It's really great to be here and to have all of you here. Thank you so much for joining us today. As Megan said, this is the first time we've done this. This is the first time we've brought together customers, partners in a room to talk about IoT, to talk about what we're doing at Particle, and to announce some new products. But I want to talk a little bit about the inspiration for this conference, because we started talking about this earlier this year, and we thought, well, what's missing right now? What can we do to create a really great event that's helpful to our customers, to our partners when we do this? And one of the things that we've found as we've spent time in this industry and as we've attended other events is there's a lot of events in this space that are focused on folks who are interested in getting into Internet of Things, to talk about some of the things that you could do. But there aren't a lot of great events focused on what people are actually doing, right? Targeted for practitioners who are in the space, who are currently solving the hard problems of creating some kind of internet-connected device with content that's designed to help tell people what are the best practices to go out and solve these problems. And so that's really the focus of today's conference, is to be for IoT developers, for IoT practitioners, for people who are currently trying to bring products to market, who have products in market, and are trying to figure out how to create some value for themselves, for their businesses, as they're doing so. When we launched our first product, the Spark Core, back in 2013, we did so at a conference called RobotsConf. Does anybody here in the room was there? A handful of folks? We were talking about this a little bit last night. And that was an event that was targeted for web developers getting into IoT, and it was a great place where we could get our hands dirty and get real people using our products for the first time. It was really exciting. And a few years back, we also were a big sponsor in an event called Solid Conference. Does anybody participate in that event? A O'Reilly event that did a great job of really focusing on, again, IoT practitioners, the problems that people are solving out in the field today. Now, unfortunately, neither of those events stood the test of time, which created this opportunity for us to create this event, Spectra, and invite you all to it. So really excited to have you all here. Thanks so much for joining. And the first thing I want to start with today is a conversation about the industry. But it can be really challenging to talk about the industry of the Internet of Things because it's not really one industry, right? It's 75 different industries that we've applied this label on because there is this common thread where we're all in the business of trying to connect some kind of physical product, but we do so in very different contexts. So when I talk about IoT, I really want to focus on the problems being solved rather than sort of the industry as it's typically described. But let's at least start to categorize this industry a little bit. What do people tend to mean when they talk about IoT? I think the most common thing that people are describing is smart home and wearable products, some kind of consumer electronic or appliance that's internet connected. And I think the reason that we go there so often is because we are all consumers, we're all human beings, we all have homes, houses, apartments, we all have ourselves that we can strap on some kind of connected thing to, right? So these are problems that are very easy for us to all identify with. And as a result, they're the ones that get the most visibility, get the most attention. And so we talk about things like connected lighting, which is where Particle originally started a half a decade ago. We talk about smartwatches and wearables designed to improve our health and fitness, set-top boxes, smart televisions to create streaming media into our homes, which has totally upended media and entertainment, as well as voice assistants that really came out of nowhere over the last 2 years and changed how we interact with our homes, how we interact with our connected products. I have a 1-year-old son right now who thinks that Alexa is a human being and will grow up with another member of our household, and that's really confusing. So, okay, that's one part that we all immediately find ourselves talking about. And then there's this whole other part of the industry that's really industrially focused, right? Robotics and automation, where robots have been around for a long time, and we've been introducing factory automation for decades, but we're now starting to do so in an internet-connected way, where these robots are communicating with one another, they're communicating with servers, these pieces of equipment in the factory are coming online. And you hear this described as smart factories, Industry 4.0, depending on where you are in the world. There's a bunch of different terms to describe it. There's also a huge business of cameras, right? If you think about just the various ways that we're putting new cameras into the world, whether we're doing so at the front of our house with doorbell cameras that make it easier for you to control who has access to your house, as well as to do things like deal with package drop-offs, and drones that are being used in consumer environments to do things like video, but are also being used in agriculture and in construction to monitor fields and buildings that are being constructed, and security cameras that are helping create more secure environments, whether that's in our homes or whether that's in public spaces that are being monitored by third parties. And then finally, we have a bunch of stuff that is a little bit hard to categorize. I call it newfangled telemetry, which is we're adding sensors to things in kind of the same way that we've been doing for a really long time, but we're doing so in new and interesting ways that are creating new businesses. So for instance, you hear a lot of conversation around GE and their jet engines, where GE has changed the way that they deliver jet engines to customers, recognizing that they're not selling them jet engines, they're selling them flight time in a plane. And if they connect those jet engines so they can monitor them and better service them, it really changes how that business works. At the end of the day, it's a remotely monitored jet engine, but introducing a new business model. And you also see that in everyday contexts like the scooter sharing market. If you live here in San Francisco or other major cities in the US and Europe, you might find that the bike lanes are being more and more filled with electric scooters that nobody owns, right? That are being rented on a dollar per minute basis or whatever it might be. And that's a completely different way of thinking about transportation that popped out of nowhere 6-9 months ago and has really changed how people are getting around cities like San Francisco. So these are just 4 categories of this endless and infinite industry that can be sliced and diced in 1,000 ways. And there's an investor, Matt Turk, out of New York, who creates this Internet of Things landscape every year, where he tries to break it all down into these different categories. And I look at this, and I mean, I expect nobody in the room can actually see these logos because they're too small. The point is there's a lot of them, and yet if you actually dug into any one of these categories, you'd find dozens more companies behind the ones that are presented here. So this industry is big and messy and complex and multifaceted, and a little bit difficult to talk about as a result. So again, let's talk not about IoT, but let's talk about how we're solving problems in some way by creating more connectivity around the world. And to do so, I want to go back a little bit in time and talk about the history of this industry. Because I think for a lot of us, we think of IoT as being a new thing. The term IoT is less than 10 years old. It's been used, it's a relatively new term. There were terms that have been used for longer, like telemetry and M2M, that mean kind of sort of the same thing. But this industry feels very young. And at the same time, it's been around for a while. In the early 1900s, we had cases where we had connected sensors using telegraphs and things of that nature. Seismic sensors in 1906, this is the great earthquake in San Francisco in 1906. There were seismic sensors around the world that were able to communicate with one another, which is crazy to think about because that was more than 100 years ago. Commonwealth Edison was measuring load on their electrical grid in 1912. And the Panama Canal, which was built in 1913 and 1914, used telemetry to be able to check water levels so they could figure out when the locks needed to be opened and closed. That feels crazy because that's such a long time ago. And in a lot of cases, the things that we're doing today feel like the natural evolution of what is now an essentially 100-year-old industry. But I think the way that we as everyday people got to know this was through what has now become an incredibly ubiquitous product that was originally popularized in the 70s and 80s, which was this smart energy meter. This is something that you might not think about on a day-to-day basis because we don't spend a lot of time looking at our energy meter, but once upon a time they were offline and now they're online. There are 70 or 80 million of these in the US. Half of American homes have a smart energy meter. And this really changes how utilities and energy companies think about delivering electricity to your home and doing so in a more intelligent way. This is really arguably the most successful IoT deployment that happened quietly around us over the last few decades. But while these things are connected products, they're not necessarily internet connected in the way that we think of the internet, which is typically sort of these IP connected, they have addresses and they're on the same network that our PCs are. The first case of what we now call the Internet of Things was a connected Coke machine in the halls of CMU. Now this isn't necessarily a real solved problem in that, I'm not sure what problem you solve when you connect a Coke machine because really when you're using a vending machine, you kind of want to be standing in front of it when the Coke drops out of the thing. I'm not, like, remotely dropping a Coke out of a vending machine isn't that useful. But at the same time, it's not that surprising that the innovations and sort of exploring the technology that we use to create these products happened in a sort of fun environment, in a college environment, connecting an appliance, which has turned into this massive industry that we talk about today. And so what I think of as the Internet of Things is this combination of these really interesting trends. One is the declining cost of computers. Moore's law says that the cost of computing is cut in half every 18 months. We've seen that happen for decades now. And what that's done is it's opened up new use cases where we can now start connecting things that we don't traditionally think of as computers, right? Whether that's pieces of equipment or whether it's some kind of physical asset. We're also now surrounded by ubiquitous connectivity, whether that means that there's Wi-Fi networks everywhere. I expect if you pulled out your phone or your laptop now and checked how many Wi-Fi networks there are, it's probably quite a few. I think near our office, which is a couple blocks from here, there's probably dozens of Wi-Fi networks available. But also cellular networks, right? Pretty much anywhere in the world, with the exception of maybe the middle of the ocean and some deep mines, you can find your way to some kind of wireless network. So connectivity is essentially ubiquitous. And third, we have this, what I would call like sort of problems of the physical world, right? Which is, there's some machine that's broken somewhere. I would like to go fix it, but I can't actually tell what's going on with it. I want to be able to connect that machine or that field or that tree or that hospital bed so that I can figure out something that's going on. And so you have these problems that start to us as invisible, but because of ubiquitous connectivity, the availability of computing power, we can now start to bring these assets online. So as a result, you see these sometimes what sound like crazy numbers in terms of the industry growth, 31% from 2016 to 2017. And by 2020, according to Gartner, there will be 21 billion connected IoT devices out in the world, which means 3 devices for every human being on Earth. And these numbers always feel crazy in terms of their size. But when you realize all of the different problems that people are solving in IoT, you realize what we're doing is we're combining all of these smaller markets into this massive connecting everything other than PCs and smartphones. So huge opportunity available, and for all the folks in this room, this is a great opportunity because it means that now is the time to be investing in IoT and be creating these kinds of products. But it doesn't necessarily mean that it's going to be easygoing, that there aren't problems that we have to overcome. And so some of those problems are some of the things that we often see cited when we read articles about the industry and media publications and the like. And one of the most common issues is about security, right? So Symantec says IoT attacks increased 600% between 2016 and 2017. We have really widely publicized cases like the Mirai botnet, where essentially a bunch of webcams were used to attack the infrastructure of the internet and took down Dyn, took down the internet in places like Liberia. And that botnet is still there, is still online. But you also have cases that are less publicized as IoT hacks. So for instance, the Target data breach in 2013. I expect everybody in this room is aware of the fact that Target had a data breach where their point of sale system was attacked and credit card information became available. And it's now totally changed payment processing. We now all have chip cards in the US, which we didn't have before, that was a problem, and now it's been fixed, sort of. But what you might not know is that the Target attack was an IoT hack. The way that the hackers got into the point-of-sale systems was through the HVAC system. They got access to remotely controlled HVAC units that were in the stores, and they used that to piggyback their way into a network that had more valuable information than HVAC data, which is financial data, right? So it's one of the reasons that we're seeing more and more security issues around IoT. We also have challenges around standards, which is that there's a lot of them. And so when we're thinking about new technologies like LPWAN, low power wide area networking, there are a bunch of competing technologies looking for your mind share to say this is what you should be using to build your next generation products. We have from carriers LTE Cat M1, narrowband, which are both really interesting and exciting technologies. But then you have other parties like Sigfox and LoRa that are creating different ways for us to connect products globally around the world. And you see that same sort of competing set of standards, whether you're looking at communication protocols, mesh networks, even the voice assistants in the smart home, where you sort of look at it and say, all of these are interesting, all of these are useful and valuable to the problems that I'm trying to solve, but I don't know which one to use, right? How do I, if I'm standing here in 2018 and I want to bring a product to market, what set of technologies should I be using to build that product? And finally, we find our attention, especially in the media landscape, really drawn by these sort of novelty products that are great counterexamples to the solving real problems thing, right? One of the products I often describe here, and I apologize to anybody who works at Wilson, is the Wilson Connected Basketball, which is a connected basketball and costs $300 and will count your shots for you, which is, okay, that's nice. But it also has a dead spot because there's a Bluetooth module stuck on the inside, and so if you dribble it on that spot, it doesn't bounce. So it's, and it's really fun. But this is, right, this is the problem. I'm here talking about this story, but we often sort of find ourselves really drawn in by these stories of these silly things that nobody needs, which creates this fog in the industry that makes it hard to talk about the real problems that we're solving and some of the most interesting applications, because these are the ones that often get the most attention. So, how do you break through the noise? So this is something that we've seen. We've now been in this industry for a little while. We have more than 500,000 devices provisioned to the platform, 160,000 developers building products with Particle at more than 8,000 companies, and millions of API calls a day. We see a ton of activity amongst all of you and the rest of the world that's building products with Particle. So we've learned some really interesting things about what seems to work or not, right? So what are the customers of ours that we see being most successful in market? Well, it comes down to whether they're solving a real and meaningful problem. So who are some of the folks that are solving these real problems? Well, one that I love to talk about is a company called Opti. Opti makes a stormwater management system that makes it easier for cities to manage the increasing quantity of water that they have to deal with. So we're starting to see more extreme rainfall, more extreme storms, like the hurricanes that we've seen in the US over the last year. And if you're a city, you have to figure out what to do with that water. You have a stormwater system that's intended to collect and move this water away so that it doesn't flood and destroy your roads, but that stormwater system was not built to deal with the quantity of water that we're now starting to see. And it may be infeasible, either economically or physically, to replace that system with something more modern that can take a larger quantity of water. So instead, you have to figure out how to use your existing system, but use it more intelligently. And so what Opti does is they provide a system that connects the pumps and valves that control the flow of water throughout the city, and they connect it to weather prediction algorithms that basically say, if we're expecting rain to come soon, we will move around water in advance of the rainfall, so that when that rain happens, we don't see flooding, but rather we see these existing bodies of water just fill back up after already being emptied. We have customers that are protecting the air that we breathe. A company called EnviroFit that makes stoves that are used in developing countries to heat homes and to cook food. These stoves are intended for environments where you're living in a small home or a hut that doesn't have airflow. And as a result, when you heat that home using a stove and burning some kind of product, or you're cooking food by burning something, you're creating toxic gases that affect your health, especially if you have kids, that can create a really unhealthy environment. And so EnviroFit creates these stoves that that allow people to burn the same fuel, but collect the gases so that the environment in that home does not become disrupted. EnviroFit uses Particle to be able to monitor the usage of these products because this product is, in some cases, funded and supported by governments and nonprofit organizations that help distribute this product around the world, and they want to show that it's actually being used in order to fund and develop this product further. And we also have customers who are reducing fuel consumption. Extreme Trucking is a company that creates a product called truck wings. Truck wings are these things that sit between the cab and the trailer of the truck that, by closing off that gap in between, improve the energy efficiency, and they can control these systems remotely. These can reduce the fuel consumed by an 18-wheeler by 10 to 15%, which is an extraordinary amount if you're managing a large fleet of trucks. Creates a huge economic advantage and an environmental advantage in that we can reduce fuel in a relatively simple and easy to deploy way. So what do these have in common? What's the common thread between these applications that work in totally different fields, in water, in municipal applications, in developing countries? It's about finding a problem worth solving and solving it. And so with that, I want to talk about some of the problems that we're solving today, some of the products that we're going to be announcing for you to use to build these IoT products and bring them to market. And I want to start by talking a little bit about networking. One of the things that we've seen our customers struggling with over the last year is the need to create wireless networks out in the field. So we have customers who will launch some kind of connected product, bring it to market, their customers will be using that product, and after they ship it to their customer, they think, you know, it would be really great if I could add some extra sensors to this product, if I can create more knowledge and insight about what's happening around that product. And we've seen customers building their own homegrown point-to-point or mesh networking solutions out in the field. And we took that as an opportunity to say, why don't we try and solve this problem for all of our customers? And so in February, we announced a set of products that we call Particle Mesh. So a quick video to talk about what Particle Mesh is.
This is the internet. Well, maybe not the internet you're used to. This is the internet for the physical world. The internet of sensors, of motors, of pumps and valves. The internet you know connects your phones and computers. This internet connects the spaces in between. This is Particle Mesh, the new internet for the Internet of Things. Hi, I'm Zach. I'm the CEO of Particle, the company that brought you Wi-Fi and cellular connectivity for the Internet of Things. Since we launched the Electron, we've become the most widely used IoT platform, and you've connected everything from school buses to sump pumps. There are 140,000 of you in 170 countries building with Particle, and 8,500 companies using our platform to build real products. You've used Particle to connect the world. Now it's time to go one step further. Today, Particle devices connect to the internet, and that's it, beginning and end. But with Particle Mesh, these devices become gateways to the internet. They create wireless networks that other devices can join. Devices that join the network communicate with one another, building a mesh of conversation. They work together to make sure the messages get where they're going. This makes the network larger as messages bounce from node to node. But it's also more reliable, because if one node goes down, the network heals. Particle Mesh is low power, secure, and reliable. And it works with all three of our new products. First, we've got the Argon. It connects to the internet over a Wi-Fi network, great for devices in your home or office. Next, we've got the Boron. It connects to the internet over LTE, which means it works pretty much anywhere. Both can act as standalone devices or as gateways for a mesh network. And finally, meet the Xenon, the low-power, low-cost mesh node. And every Xenon you add grows and strengthens the network. They're easy to set up, easy to program, easy to manage. And they can be used for pretty much anything. Whether you want to count your inventory, monitor your environment, or tell people where to park, we're here, bringing the physical world online so you can see more of what's happening. Pre-order Particle Mesh today, shipping in July 2018. And then the only question is, what problem will you solve first?
So to talk more about Particle Mesh, I'd like to bring up on the stage Will Hart, General Manager of our prototyping business.
Hello, everyone. Can you hear me okay? Great. So as Zach mentioned, my name's Will. I'm going to be talking a little bit more about Particle Mesh. You may also recognize me as the guy whose shoelaces got untied in that video. And I'm not wearing any shoelaces today, so hopefully things go a little bit more smoothly. Like Zach said, 5,800 customers pre-ordered 35,000 devices, which made the Mesh announcement our most exciting and most successful product launch ever. And we are really thrilled with that response. And you know, there's a lot to be excited about with Mesh. And I'm going to talk about some of those things today. Compared to existing Wi-Fi and cellular connectivity, Mesh offers a lot. Cost. Zach mentioned that one of the things that will really impact the availability of IoT devices is ubiquitous connectivity. And part of that means lower cost connectivity. Mesh offers the lowest cost of connectivity per device that's available versus Wi-Fi and cellular today. Power. It also has huge benefits for power. Mesh consumes less power than Wi-Fi and cellular devices, which means new kinds of things can be connected, like wireless sensors that are fully enclosed that can last even months or a year without needing to be recharged. Finally, reliability. Compared to Wi-Fi, mesh networks get stronger as you add more devices to the network, which means that when you need to deploy lots and lots of connected things in the same environment, you can rely on the backbone infrastructure of mesh networking. But besides these features, one of the things that's most exciting is about how it changes the way that devices can talk to one another. So today, if you have a Wi-Fi or cellular connected device, that device is directly connected to the Particle device cloud. To communicate between one device and another, a device sends a message to the device cloud, which then receives that message and routes it to the correct recipient device. But whenever you're in a situation where you want to connect multiple devices in the same place, that doesn't make a lot of sense. Again, providing an expensive cellular connection to every single device, especially when they're sitting right next to each other, can increase the average cost of connectivity beyond what's suitable for some applications. And then you're also introducing latency between two devices sitting right next to each other that need to communicate. With mesh, this is different. Every single mesh device has the ability to create a local mesh network that other devices can join to communicate directly with that device. What that means is that devices can now join the same network, share information, and make better decisions as a group, and turn individual smart products into smart IoT systems that work together to make intelligent choices. So we're going to have a little fun with Particle Mesh hardware today, and we're going to do a demo. The demo we're going to consider is this horrifying example of home flooding. Now, I hope none of your homes have ever flooded quite like this. Again, this is a little bit of a dramatic depiction, but coincidentally, it actually looks a lot like the connected living room that we've created here for us to play with. We actually bought this toy furniture before we even found this, so really this is a pretty amazing coincidence. But we will be ruining it in the exact same way, which is by pouring water through the ceiling. So to get started with this demo, I want to introduce you to the actors that will be playing roles here. So first, there's a smart water meter. So you can imagine this in a connected home. This is a water meter that measures your water consumption so that you as a homeowner can manage your water usage and your water bill. It could also tell you if there's a pipe burst, your water usage goes through the roof, might be something you want to check out. We'll also have the help of a flood detector. So this is going to detect the presence of water and alert the rest of the system that there might be flooding happening. And then finally, a pump controller, which you can imagine control your sump pump. It's going to help us pump the excess water out of the living room, I guess. So here's how those devices are connected today. Starting, we've got this is our smart water meter. Now, I want to highlight, you can see that this device is breathing cyan. This is actually a xenon that's been placed inside of our Ethernet featherwing. So this is connected to the Particle cloud over Ethernet. So that's one of the new connectivity technologies that's now available with our third generation of hardware. This device also has a mesh radio. So it's creating a mesh network that the other two devices can join to send and receive information to the internet. We've also got here, this is our smart water sensor. So you can see it's also breathing cyan, but it does not have a direct connection to the internet. So as you can see, it's connected to our smart water meter, which is acting as the gateway in this example. It doesn't have a cellular radio. It doesn't have a Wi-Fi radio. It's only connected wirelessly to the mesh network that's been created by the smart water meter. And finally, the same is true about our pump controller over here. So it's breathing cyan, connected to the same local mesh network so that it can send and receive messages, but doesn't have any other form of direct connectivity to the Particle cloud. So what are we going to see in this demo? We're going to see three things. We're going to see that Particle mesh devices, even though they don't have an internet connection, can still publish messages to the cloud just like any other Particle device. So it's going to use the connectivity of our gateway here to make sure that that message gets safely routed to the internet. We're going to see that these devices, mesh devices, can also be remotely controlled from the cloud, just like any other Particle mesh device, even without a direct internet connection. And the third thing we'll see, which is unique to this new generation of mesh products, is that devices that are on the local mesh network can still communicate with each other even without a connection to the internet. So we're going to, later in the demo, we're going to remove this Ethernet cable, have an entirely local network, and show that these devices can still interact with each other even without the connection to the device cloud. So Jonathan's going to help me with this demo. Oh, excuse me, there's that third point. So this is the console that we've got up here. You can see there's a variable water detected, which is reporting once a second. Currently, water detected is false, so we're going to change that. So here we go. Pour some water in. And what should we see? We should see that sensor say, OK, I now detect the presence of water, and that field has been changed to true, right? So again, what's happening here? This device is connected to the sensor. It's detected the presence of water. It's communicating that information over the local mesh network to this gateway, which is then relaying up to the cloud. Very little latency, very fast, very highly performant. So that's the first example. Particle mesh devices can publish information just like any other particle product. So now that we've got a living room full of water, we're going to try to empty it out. So we're going to switch over to the secondary device, which is this pump device. We're going to scroll down here and see that it's got a function available, toggle pump, right? Just like any other particle device, you can see the functions that are available on that device and interact with it from the cloud. So to get the water out of here, we're going to change that toggle pump argument to on. And what you should see, and here it is. I don't know if all you can see in the back, but we've got a little pump now that's pulling the water out of our little tank. Right, yeah, woo! It worked! So if you've been using particle devices, you know that none of this is particularly new. So for the third bit of this demo, what we're going to do, let's see, it's almost out. So the third bit of the demo, what we're going to do is I've got, this is the Ethernet cable that's going to this device, again, giving it a connection to the device cloud. So I'm going to detach it. So what you're going to see is this device here, after a second, should start flashing green. And that flashing green indicates, as you all, if you've used Particle, know, that's that anxiety-inducing state, right? Not connected to the internet. So there it goes, flashing green. So that means this entire network is now disconnected from the Particle device cloud. So these devices still have the ability to communicate, but they're no longer sending and routing messages through the device cloud. So what we're going to do here is now demonstrate how devices can use local logic at the device level to make better decisions together. So for this third piece of the demo, when the flood sensor detects the presence of water, it's going to publish a message to the mesh network using a new particle primitive, mesh.publish and mesh.describe. And what we're going to see is that this pump is subscribed to that local message, and even, again, without a backhaul to the internet, they're still going to be able to interact with one another. So we're going to do the same thing again, pour some water through the roof, and see what happens. Might have to use the second bucket here, too. There you go. Woo! So I'm going to reconnect this Ethernet cable for use later in the demo, because we're not done with our flooding living room yet. But that's going to wrap it up for this portion of the demo. So we've been talking a lot about mesh hardware, but I want to also add that there's a lot of great software support shipping with Particle Mesh as well. Every Particle Mesh device has a Bluetooth connection. So we've managed to even further simplify the setup process by using that Bluetooth connection and introduce new functionality, like local device diagnostics over Bluetooth. And finally, we're making it easy to manage the networks that you've deployed from the Particle console, again, to make administering Particle Mesh networks simple as well. So as we mentioned in the video, Particle Mesh is actually composed of 3 different devices. The Argon, which has Wi-Fi and Bluetooth and can act as a Wi-Fi device or Wi-Fi gateway. The Boron, which adds new LTE M1 capabilities, the newest iteration of the cellular standard for IoT, as well as Bluetooth and Mesh. It can act as a cellular product or as a cellular mesh gateway. And finally, the Xenon, which has Bluetooth and mesh connectivity, and is also our most affordable development kit ever, starting just at $15. If you all have your goodie bags, you should see that you've got a Xenon and an Ethernet Featherwing in your bag, the exact same hardware that we used to demo today. So hope you have a lot of fun experimenting with that. And if you have questions about how to use those products, you can talk to anybody here on the Particle team, and we'll help you get set up. But we've actually got one more hardware announcement today, which is brand new. This is releasing this information right now here at Spectra, which is introducing our Particle Mesh SOMs. SOM stands for System on a Module. So if any of you are product creators, you know that the kind of hardware that does well in the prototyping stage doesn't always translate smoothly to mass production. So these SOMs, again, System on a Module, are the new professional hardware for enterprise deployments of Particle Mesh. So one thing you might notice is this looks different from our other mass production hardware products. And so I want to talk a little bit about the M.2 form factor. So all of these products comply with a connector standard called M.2. And it's actually a successor to the mini PCIe standard, which is used oftentimes in computers for storage and compute. What do we like about it? It's got a smaller PCB footprint. So it's double-sided. So that means the amount of space it takes up in your product is smaller than ever. It's also a standardized form factor between all of our new third-generation products, which means that with the same connector, you can add Wi-Fi connectivity, cellular connectivity, or mesh connectivity. Again, the pinout is exactly the same. It also makes for easier upgrades. So one of the things we notice is that, take for example, in the cellular space, the standards that we use to connect products are rapidly evolving. So what this means is that with the M.2 connector, you can more easily upgrade your product. You can swap out your you can swap out your Particle SOM and replace it with either, if it's been damaged, you can replace it, or you can upgrade it to the latest and greatest technology as this quickly evolving industry continues to grow. So these SOMs are going to be available in Q1 of 2019. We're sharing them here with you today. They're going to come in 3 varieties that mirror the argon, the boron, and the xenon: the A series, the B series, and the X series. And we're really excited to see what you build with it. Thank you.
Thanks so much, Will. I feel confident knowing that my tiny living room will never fill with water again. So it's really exciting to share with you our next generation hardware, not just the products that we've already shared with Particle Mesh, but these new SOMs that are going to come out for the first time early next year. But I also want to talk a little bit about the software side of IoT. What does it take to build out a software application to build an IoT product? So typically, the way that we see our customers building products with Particle today is that Particle takes care of a lot of the device-side infrastructure, right? So we provide the technology that's embedded inside the device. We provide the device cloud that connects that device to the web and exposes those devices via an API. And then our customers generally build some kind of custom web application that provides the back-end logic of what the product actually does. And so that'll deal with things like data ingestion, data processing, business rules, third-party integrations, notification services. So if you say, this machine is broken and I need to notify somebody, I need to create a ticket in some system, or I need to send somebody a text message to go and fix it, that's generally going to be built custom for each individual customer. And one of the reasons that it's generally built custom is because every person has a different requirement here. Every product requires a different kind of software, and our product has generally been designed for developers and engineers to have the tools they need to build the things that they want to make work. But one of the things that we've seen is that our customers might not always have the engineering resources available to build out all of the software to do the things that they want to do. We find that when customers bring their IoT product to market, they quickly realize there's 700 things that they want to do with this, each one of which requires that they build some additional piece of software, and they might have a couple engineers available to do that. I was speaking with a customer last night who was talking about the challenge of building out an engineering team to do all the things he needed to do to solve problems for his customers. And so we want to simplify this. We also recognize that our customers often have folks around the table who aren't engineers, who don't have an engineering background, but are interested in being able to solve some of these problems directly. Whether that's folks on the marketing team who want to be able to access the data about how the devices are used to learn more about their customers, or in customer service who want to have access to the devices, so if somebody calls in and says there was a problem, they can have direct access to the information. So there's other people around the room who'd like to be involved, but might be intimidated or unable to participate if there's a wall of code between them and the problems they're trying to solve. And so we're excited to announce a new product today, which is called the Particle IoT Rules Engine, which is a drag-and-drop visual programming interface for building IoT web applications. And to talk more about this product, I'd like to introduce one of our senior product managers, Jeff Iden.
I'm super thrilled to be here with all of you today and share this amazing new product with you. So as Zach alluded to, when we set out to build the rules engine, we were focused on solving two main problems. The first was simplifying the process of bringing an Internet of Things product to market. And the way that we wanted to do that was by drastically reducing the number of things that you had to build outside of Particle. And the second was around accessibility. So for many of you IoT practitioners who have started down your journey of building an Internet of Things product, what you quickly realize is that it's a transformative decision, and it involves not only the engineering part of your organization, but truly everyone around the table. So we wanted to make sure that we provided a solution that you didn't necessarily need to know how to code to use. So we're really thrilled with the result. It's the IoT Rules Engine. And when people ask me to describe the Rules Engine, I start with this. It's an if this, then that style application builder designed specifically for the Internet of Things. It allows you to build conditional logic to react to what's happening in the physical world, i.e. data coming back from your Particle devices. And it's all visual using a low-code, drag-and-drop visual programming environment. So without further ado, let's see how it works. So here it is, the Rules Engine. This, yeah. I haven't shown you anything yet. I don't know why you're clapping. This is the canvas by which anyone on your team can create incredibly powerful business rules with very simple building blocks. And in the Rules Engine, those building blocks are called nodes. There are many different nodes that you have available in your palette, and each one of the nodes has a very specific and well-defined purpose. And I want to start by calling out the particle nodes, which is essentially how the Rules Engine plugs into the rest of the Particle ecosystem. So you'll see 5 of them, but I want to highlight 4 of them: publish, subscribe, variable, and function. And if you've ever worked with Particle, you've probably come across these. These are the 4 main communication primitives that you use to interact with your devices. So let's get a sense of how it feels to actually work with the Rules Engine. So I'm going to use the subscribe node and build off of the amazing demo that Will gave earlier in the presentation. So to use one of the nodes, you simply click on it and drag it onto your canvas. It's actually that easy. And I'll zoom in so you folks can see a little bit better. And each one of these can be configured to work exactly the way your use case needs, so really flexible to adapt to your particular use case. So I'm going to have it listen to the same event that the flood sensor is publishing, and it's called water detected. I made a typo with this earlier, and it wasn't working, so I'm being very careful that I get the event name right. So I'm going to click Done, and then what I'm going to do is I'm going to attach this to the debug node. So the debug node, we're making a very simple flow here. It allows you to basically see the output of the event come through in the Rules Engine. And to connect 2 nodes together to make a flow, it's literally click and drag. And when you're ready to actually get these flows working, you click on the deploy button. And you can see that we're getting notification that events are coming through, and you now see the same event that was being published that we were looking at the console coming through in the Rules Engine. So let's make this a little bit more interesting. So what if we took a lot of the logic that was driving the demo before and moved it into the Rules Engine? How would that look and how would that work? So let's start with the same water detected event, but let's layer on that conditional logic aspect of it. So this is a node that's called a switch node, the one that says water detected. It basically allows you to route messages accordingly depending on what the payload, the data that's coming through with that message is. So if water detected equals true, you're going to route that message to the top flow here. And if water detected is equal to false, then you're going to route that message to the bottom flow. So in that case where water is detected, we are then going to call a function on the second device, which is the pump, to turn it on. And then to show some of the third-party integrations capabilities of the Rules Engine, we're going to pull in the Twilio node to actually send an SMS-based alert to the homeowner to let them know that water has been detected and they need to be aware of that. So I'm going to need some help from my friend Will. I'm going to enable this flow, and I'm going to deploy it. And so he's going to pour the water in once again. The pump turn on?
Yep.
Great. And if luck is on my side, we'll hopefully see a text message come through. Well, live demos can't go perfectly, can they? So that's just designed to give you a sense of how programming with the rules engine can work. One other thing to call out briefly, we have the function node. So for those of you who are more technically minded and do enjoy writing code and find it to be your tool of choice, the function node actually allows you to write custom JavaScript logic for maximum flexibility and control of your rules engine instance. So you can essentially have your cake and eat it too. And for some of you, I just want, for the record, to show you that the text did come through. Problems outside of my control. So not only do you get the text message that says water detected in basement, but after the pump had successfully extracted all the water, you get an all clear notification as well. So we see that message being routed through the rules engine. So if you've been working in the IoT space for a while, this interface might look familiar to you. And that's because it is. And Particle has built our rules engine on top of a very popular, well-adopted open source tool, and it's called Node-RED. Node-RED is an IBM-sponsored project. It's also part of the JS Foundation, which Particle has now joined, and we're really excited about that. And for you Particle customers and people who are using this tool, the amazing thing about building on top of this open source tool is that there's this thriving community who are contributing open source nodes that you can easily pull into your own flows, which greatly enhances the extensibility and flexibility of what you can do. So I really encourage you to check that out when you start using the rules engine. And so to talk about that a little bit more, we have a special treat. We have Greg Gorman, who's the Global Director of Developer Advocacy at IBM, who knows everything about Node-RED, and he's here to share a little bit more with you today. So welcome, Greg.
Thank you. Thanks a lot. Okay. All right, well, I guess we'll see how well this all works. Like I said, the stuff with live demos and things is always fun. I assume I can click this and get back to the slides, or somebody back there behind the crazy people behind the mirror can put me back there. If I do that, yeah, here we go. All right, so this is great. First of all, I think I've got the dreaded green flashing light here as well. I think the cellular connectivity is about one tiny little bar here, so it's not working all that great. But Node-RED is a pretty neat application. One of the people on my team conceived it a few years ago, saw a need for making things very easy. How the best way for them to connect things to the internet, and also to obviously make IBM's cloud easier than anybody else's. I mean, that's part of the plan, right? And we saw it really take off. It's been really popular. It's got this neat little browser-based editor. You have to install anything you saw in the demo, just drag and drop kind of thing. It's very easily done. It's all written in JavaScript itself, so it's pretty simple. The runtime is Node.js as well, so it's fairly fast, portable. It runs on all kinds of devices. Obviously we've got it running on Raspberry Pis and clouds, and it runs on Amazon and Google and everywhere. So I've seen people run all kinds of different containers. Any place that Node.js runs, you can run Node-RED. So that's pretty exciting. And then it's also very extensible. It's very simple to add your own nodes to the palette. You can customize it like crazy. It's all open source, and we have a number of companies that have taken the core of Node-RED and either forked it to build some of their own products or are contributing back to the Node-RED environment itself and helping us continue to grow it. One of the things I want to talk about is we hit the 1 million installs milestone back in February this year. That's pretty exciting. That's pretty big. And roughly half of that is our cloud installs. The other half are out on some kind of devices like Raspberry Pis or other kinds of embedded devices like that. And then also about a year ago, or I guess it's 2 years ago, yeah, I guess it has been. It seems like a nightmare. Maybe that's why it seems so recent. We worked through all of the legal side to push this code over to the JS Foundation. So we were having a little bit of trouble with people adopting it just because, ooh, it's big bad IBM, they're going to steal everything. It's like, come on. We've been doing open source since probably before most of you have been born, right? 92, how many people are, yeah, I mean, my kids are younger than some of the stuff we've been doing. So we've been doing open source for a long time and know how to do this stuff. And it just became so popular, we're like, all right, let's get out from under it. We want more people to be able to participate. We think it's a great product, a great tool, and are really driving forward on it. Nick O'Leary, who's the original founder of it, is on my team and still works for me, still works for us. Great guy. He's always active on all of the channels, has a plan for development for the next several years. We would love to have your help. We're looking for contributors and as many people as you want. Jump in, have some fun with it. If you don't like what it does, come in and fix it, because that's kind of our, that's the way our attitude is on that. And I guess this never really connected back up, but I was going to show you guys how boring and unengaged you are. This is a particle internet button, as you can see, and this is one of those useless devices. Some of you may see this. If you do a quick search, you'll find my recipe for how to build this thing. It's connected to Node-RED on the cloud, and all this thing is doing is showing colors. But the colors are important because they're showing the sentiment of the tweets you all are making. And it's looking for the Spectra 18 hashtag. And then each time a light comes on is another tweet. And like I said, when it stopped, like I said, man, it's just barely. I'm trying to get it to, my phone's hot spotting, and it may or may not get a good signal depending on where it's sitting. And it's showing you, neutral is white, so you guys are all boring, like, yeah, okay, Zach's talking, and he's pretty cool, right? And then, now it just reset. One of the others was, probably the red one was something like, my seat's too hard. And maybe a couple of green ones, hey, cool video. So the idea is to look at sentiment on there, and if this thing actually works, I can even show you some other ones here. Let's try this button, if it'll work. And it shows it in real time. So I just, using Node-RED, a Twitter node, pulling little search terms off, then running it through a sentiment analyzer, and then sending down just a color code to this so that way I can keep up. Because I came up with this idea during the presidential election a couple years ago, and using 2 search terms of our favorite candidates, and it was actually pretty clear even in September when I was over in the UK showing this off, about the kind of engagement, the kind of passion that was involved, and the tweets per second were pretty clear. I guess, I don't know, it's not going to connect up, so I guess we'll just have to give up on it. If you see me walk around with it later today and it's actually working, then that'll be fun. I'll just try and keep it on most of the day and see if it'll work. But it's actually pretty fascinating to see the kinds of things that'll happen and the performance of it. Let's see if it'll, let's see if I get I don't think we're going to get it to go. Probably not. Part of the problem is, too, when I push the button that has the Trump search on it, it overloads everything because it's such a huge fire hose coming off of Twitter. All the buffers fill up and all kinds of crazy stuff, so it's pretty fun. With that, I want to pass it back because we have a lot more things to talk about. Thank you. I'll be...
So to wrap up, we just showed a sliver of what's possible with the Rules Engine today. There's a workshop later in the afternoon that I encourage you to come to where we'll explore some of the other ways you can use the Rules Engine. And we have a beta program that has been launched today. You can apply for access at particle.io/IoT Rules Engine. And I'm going to pass it back to Zach.
All right. Thanks, Jeff, and thanks, Greg. Really exciting product that we're building on top of. Node-RED is a spectacular product, a great community around it, and we're really excited to incorporate it into our technology stack and make it easier for our customers to be able to build the software applications to power their IoT products. Now, speaking of software development, the Rules Engine is all about making it easier to build software applications that run in the cloud that power the back-end logic of your IoT devices. But the other place that software runs in the context of IoT is on the device. And a lot of the things that we've done here at Particle is make it easier for people to write and deploy software out to their devices. Over the last 5 years that we've been doing this, we started with a web-based IDE so that you can log in. You don't have to have anything on your system. You don't have to download the tool chain. And you can start writing code and deploying it out to your devices. We added a desktop IDE a little bit later. And one of the pieces of feedback that we've gotten about the desktop IDE is that something that we should really deeply invest in, that we should create a really professional develop environment that provides the set of tools that customers expect when they're developing a product that they intend to bring to market. So I'm excited to announce one more product today, which is Particle Workbench, a professional desktop developer environment powered by Your favorite IDE, your favorite development environment, Visual Studio Code. Yeah. So to talk more about Workbench, I'd like to introduce you all to Jonathan Barry.
Thanks, Zach. So when we decided to look at our developer experience on the desktop, we talked to our developers. And we got a lot of feedback. And the number one and number two pieces of feedback was support Visual Studio Code and build a local compilation environment. And if you're wondering why that's important, well, we asked those developers to give us more information. And they said sometimes they're out in the field, they're at a client site, and they don't have access to the internet. Or they're on a plane trying to finish a project. And as they're building more complex applications, they need a tool that can handle larger applications. They're collaborating with their colleagues that a simple web editor just couldn't handle. So when we decided to build Particle Workbench, we made sure we delivered on local compilation that works offline, scales to building more sophisticated professional applications, and we wanted to also make sure that it was really easy to configure. And to stop telling you about it, I'm going to show you about it. So let's switch over to the demo. Great. So here is Particle Workbench. For all those who applauded to Visual Studio Code, this is Visual Studio Code running Particle Workbench. And I have a Particle project already set up and configured, and I'm going to start typing some code. So as I begin to type Particle, you see the auto-completion coming up. And that's because Visual Studio Code includes IntelliSense. And we've wired up the device OS, our embedded operating system for Particle devices, into Visual Studio Code's IntelliSense engine. And it works automatically and gives me suggestions. As I continue to type, it scans for different methods I might want to use. This MacBook Air is a little slow. But yeah, I was looking for the publish function. And it goes even further to give me suggestions of parameters I might want to enter into that function. Yeah, cool, right? So this is what you expect from a powerful tool like Visual Studio Code. And I'm going to say, set temperature to 10 degrees C. Now, if I'm unsure how this function is going to behave, go deeper and use the built-in functionality of Visual Studio Code to go and see the actual definition of that function without even leaving the screen. So if I hop over to peek to definition, I can see how that function in the device OS is constructed and learn how I can best use that capability. Sweet. I mentioned that the number two feature requested by developers is local compilation. So I'm going to show that off. Hopefully the demo gods are smiling on us. And I'm going to start that local compilation. And there you go. The application is compiling locally on my machine with the device OS. Yeah. No errors, too, which is great. The way we made this possible, both the integration with Visual Studio Code's IntelliSense and the local compilation, is through a brand new dependency manager that we created for Workbench. And now, I said this needs to be easy to configure. And Workbench automatically downloads the device OS, our build system, our compiler, and all the dependencies you might need to program and debug your particle-based applications. But Workbench does more than just make local compilation easy. It also takes advantage of the rest of the Particle platform. So as an example, I can fire up the command palette in Visual Studio Code and start installing a library. So if I go to install library, I'm going to use the Asset Tracker library, which is quite popular, and hit enter. And what's happening is Workbench is downloading the Asset Tracker library, which is one of the 3,000 libraries available for the device OS, pulling in all of its dependencies, and even throwing in some sample code along the way, all straight from Visual Studio Code. And we mentioned Visual Studio Code a bunch, and that's because we get to take advantage of all the great features that are baked into Visual Studio Code and all the great extensions available for Visual Studio Code. And just to throw out a quick example, Visual Studio Code has some great integration with Git and the recent GitHub integration. And I can take this project and immediately create a Git repository right here and deploy that to GitHub and start collaborating with my colleagues. And to tell you more about why we're so excited about Visual Studio Code and why it's the #1 editor of choice for developers, I'd like to introduce Amanda Silver, who's the Director of Program Management at Microsoft for Developer Tools.
Thanks. Thanks for having me. Good job. Can we go back to slides, please? Hi, everybody. Thank you for having me at the Particle Spectra event. First of all, I'm really excited to be bringing VS Code to all of you guys as developers. I've worked at Microsoft for about 17 years, always working on developer tools. So this is a place that's really, really passionate for me. I'm very, very passionate about kind of developer tools and how they work. And I know that VS Code is a beloved product for a bunch of different reasons. And a lot of that is based on the productivity that it delivers to you as developers. But let's talk a little bit about what VS Code is. It's, according to the Stack Overflow survey from 2018, it's actually the most popular development tool in the world. I think it just barely edged out the classic Visual Studio by about a point. I think VS Code was 34%, and Visual Studio was 33% or something like that. We actually have, as he showed, not only a powerful editing experience inside of VS Code, but also debugging. And the editing experience, how many of you guys are full stack developers, not just IoT on-device developers? So we have support for basically every programming language inside of VS Code. So if you do C on device or C++ on device, but you do Node and TypeScript or JavaScript on the back end, or you do .NET on the back end, VS Code, you would be able to have all of your application hosted inside of your developer environment now, which is pretty exciting. We also have the full debugging capabilities, as he showed, directly built into VS Code. So you'll be able to debug on device as well. The other thing is, if you're a container developer, let's say, and you use Docker a whole bunch, we have fantastic support for Docker directly inside of Visual Studio Code. And if you need to connect to a cloud, let's say you connect to AWS or IBM or Azure, as the case may be, we have support for all of those clouds inside of VS Code as well. In fact, we have about, if you think about the overall community of VS Code, we have about 4 million monthly active users of VS Code overall. So if you think about the momentum of that developer community that we're supporting and kind of the enterprise scale that's required to support all of those developers, all of that is in VS Code. It's powered a lot not just by the Microsoft community, but a broad community of open source developers that are contributing back to VS Code. In fact, it's the #1 most contributed to project on GitHub. And part of that is in the core project, but part of it is also in contributing to the marketplace of all of the extensions that are available in VS Code. So no matter what you want to do, we probably have an extension for it that will allow you to do it inside of VS Code. Now, Visual Studio Code is developed in the open. We publish our roadmap every month. Each month we have a public iteration. We tell you exactly what work is being planned for that next iteration. And it's all based on community feedback. So if there is an issue that you want us to resolve, you just submit it in GitHub, vote it up, and we will take care of it in timely process. We have multiple iterations. We have both a kind of release track, that is the stable channel, and then we have a nightly build as well that we also release. Visual Studio Code not only consumes, but also contributes back to hundreds of open source projects. Visual Studio Code itself is actually built on Electron, which is from GitHub. And so, this is all part of a larger open source community overall. And the Visual Studio Code team operates under the principle that there should be zero distance between our engineering team and the community of developers that use our products. And so that means that when you are filing an issue on VS Code and you're getting feedback, that is actually feedback from one of the engineers on our team who actually works on the VS Code product. It's not a support engineer who is, in some far-off land that's not as familiar with the code base itself. It's actually from our core engineering team. I mentioned a minute ago that VS Code is one of the most popular projects on GitHub with the most contributors. We have about 25,000 contributors to VS who have contributed to VS Code over the past couple of years as VS Code has been out. So with that, I will welcome the Particle guys back up. Great, thank you. And I should just say, we're really excited to bring VS Code to your community and to welcome everybody in the community to ours.
And so are we.
Thank you.
Thank you, Amanda. So we're really excited about Particle Workbench, powered by Visual Studio Code. And we want to get into the hands of developers to give us feedback on how we can make it awesome. So starting today, we're opening up for developer preview. And you or your developers can go to particle.io/workbench to get access. And there's a ton more features that we've been building into Workbench. And later today, if you're here at Spectra, we're going to be doing a walkthrough of all those features. And now, I want to hand it back to Zach.
Thanks, Jonathan, and thanks, Amanda. Really excited about Workbench, really excited to be incorporating Visual Studio Code into our technology stack. And I also want to highlight, this Visual Studio Code is now the #1 development environment, and it got so in an incredibly short period of time. It existed, what, 2 years? 3? 3 years. It's a three-year-old product that skyrocketed from no users 3 years ago to the #1 development environment in the world. It's an absolutely incredible trajectory, which I think shows how high quality of a product and an experience it is. So really spectacular product there. OK, so we talked about 3 things today. We talked about Particle Mesh, the products that we announced in February that we're now starting to ship to customers and that you have in your goodie bags here, as well as our SOMs that will become available in Q1 to help you take those mesh-based products and bring them to production. We talked about the IoT Rules Engine that makes it easier to develop a software product, and the software backend to power an IoT product. And we talked about Workbench, our new professional-grade desktop IDE to make it easier for you to build the software that runs on the device. And I want to come back to the point I made about solving problems. In each of these cases, what we've done with these products is find technologies that exist today that we can provide in an easier-to-use context for our customers to be able to build the IoT products that you have that solve the problems that you're facing in your business. So when you're thinking about your product, what I'd encourage you to do is ignore the hype around the industry, ignore the anti-hype around the challenges in IoT, and find a problem we're solving and solve it. So the next stage here, I'd like to reintroduce back on the stage Amanda Silver and Greg Gorman, as well as bring up Grant Erickson, who's the president of the Thread Group, to talk more about open source and open standards.